Okay, recording has begun. So today we're going to kind of take that thought process a little bit further. Let me actually try to dim the lights here a little bit. Nobody fall asleep, me included. So today what I want to do is kind of show how we might start to set. So Grasshopper in and of itself, creating a circle with tangents or points isn't all that useful, really, because you can create a circle pretty quick in Rhino, and it's not going to, creating it in Grasshopper isn't going to really solve any problems or make anything easier for everybody. So what I want to try to do today is at least start to set up relationships between things, right? So we got a tangent. So you set Ryan, you set up two curves that you then kind of link to that. Anybody what is another way somebody created a circle? Haley.
Number sliders.
Was that point the center, or was that point multiple points created the circle?
It was this is 2 points.
So correct me if I'm wrong, Haley. You constructed a point with sliders, right? So you had a number slider. I'm just going to adjust this. Everybody remembers, double click on a slider. You can change from real numbers to integers. You can update the maximum. I'm just going to make that 200. Okay. So you had 3 sliders that you plugged into your XYZ, which creates a point that I can move around. And then you went in. You have 3 of these. Yeah, so you went into curves, primitives, circle 3 points, and you plugged your point A, your point A, your point B, and your point C. Okay. So then if I adjust the points, wherever they go, it creates a circle that touches all 3 points. Right. Okay. And what else? What are any other ways? So we got tangents. We got 3 points. Any other methods?
I'll put it in a circle versus kind of like this. But you set 3 points and it makes a triangle out of those 3 points. And then
so the triangle, yeah, similar. Okay, so the in circle of the triangle, right? Okay, similar, very similar. The in circle here. So you plugged in the points here.
Yeah. Basically.
And then plug that in right? Yeah. And it creates a circle there. So that is if I was to, it is what the difference is. So see, there's 2 different circles, right? So Haley's circle is a circle that's touching all 3 points, right? And Ryan's circle, if you can imagine a triangle, it makes those points. The circle is inside of the triangle. It's inscribed in the triangle, right? So that's 2 different methods. Creates 2 different circles, but with the same points, right? So same but different. Any other methods? It's not that many other methods to do it. Martin. What? I'm sorry.
Circle fit.
Circle what? Fit. Fit. Okay, so then that one is many points. Did you create the points in Grasshopper, or did you drop a bunch of points into Rhino?
I didn't put it on Grasshopper.
Grasshopper, right? Okay. So if I was to, how out of curiosity, Martin, what did you do at this point? Did you just where you have 1 plug?
Yeah.
So what did you do to plug into there?
So I used
So you did that, and then you just kept connecting them like this? Is that what you did, or? Similar, but it sounds like it was different. What's that? More simpler than that?
Yeah.
So what was more simpler than that? Okay. But where did you? Oh, you dropped them in line. Okay, yeah. So yeah, that's what I thought. So you dropped points into Rhino, blah 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 blah, points everywhere. You used a point node to select all those points. You set multiple points to that singular node, and then you plugged it in there, right? So, okay, yeah, simple. You know, I wouldn't call it simpler. Different, we'll say. But yeah, I appreciate that. So you can also do it that way. So this the only difference is on purely in Grasshopper you had Rhino components and Grasshopper components, which is fine. Isaac, looks like you're raising your hand.
Yeah, is there any way you can share your screen so I can...
Oh, shucks. Sorry. Yeah.
No, you're good.
You're just watching me walk back and forth. Can you see that now, Isaac?
Yeah, perfect, thank you.
Perfect, yeah, sorry about that. You didn't have any questions though? How did you make your circles in any different way other than what we discussed?
No, I did tangent as well, and like the 3 points.
Okay. Cool. So, what'd you do? So you use the plane, so in the radius, right? So in this one, I'm gonna delete these for now, so we don't have those. So it automatically plops a circle in there to start with, so you don't actually have to do anything else in theory. But you could plug a number slider in here and adjust the radius like that, right? Cool. So, very cool. So, now what I want to do, we'll pick it up a tiny little bit of a notch. Has anybody ever heard? What I want to do now, and what will be part of your assignment for Thursday, is I want to take one of the methods you use. It can be the easiest one, doesn't matter, of creating a circle. And then what we were going to do is manipulate that using some other data, right? So we're going to take that circle and then start to create something out of it, right? So the goal of tonight I might try to do, which is, not super advanced, but it is starting to get a little bit more advanced, is to create what we call an attractor point. Has anybody heard of that before? Okay, so what we're going to try to create tonight is we're going to create a bunch of circles, and we are going to change. I'm trying to think. I didn't plan. I thought we would go a little simpler than this, but I feel like you guys need a little bit of kick. You think of how we might. So what I want to do is create a bunch of circles that their radius is changed based on their distance to something else, right? So called an attractor point. So the closer it is to that thing, the bigger the radius is. The further away it is from that, the smaller it is, right? So we'll put a point in Rhino that we move around, and then the circles, hopefully, if we do it successfully, will change in size and radius.
So the radius isn't a number, but it's more of like a relationship?
It's still a number.
Well, yeah, but you're not putting in like a number.
I'm going to generate numbers. I'm going to create a bunch of circles, right? And then we'll do it a way that is the easiest way I can think of right now, but there's 1,000 ways to do this. And we'll create some sort of relationship. We'll say the radius is based on the distance from the center of this circle to another point, right? So it's still a number, but we're letting Grasshopper tell us what that number is based on a relationship, right? Does that make sense? Any other questions or? Concerns about that? All right, so let's see what we can do. So we're going a little off the cuff here, so excuse me if we have to backtrack a little to get where we want to go. So I'm going to create a circle. I'm going to use I'm just going to use the circle by center point, right? So I'm going to create a point as well. Always a little slower here, so let me. Oh, I don't want a vector, sorry. I want a point. Put some number sliders in. I'm going to change the number slider to go up to 100. Oops, but I want it to be real numbers. Or integers, I mean, I'm sorry. Oops, not one thing. Copy, I'm going to paste this, so I'm going to paste this 3 times, right? And if you guys can follow along, you know, please do, and let me know if you have questions. So we used the constructor point node. I made 3 sliders that I then plugged in X, Y, and Z. I'm actually going to disconnect, now that I think about it, I'm going to not plug in the Z coordinate. I want to just stick in a 2D plane, all right? So I should, when that's all said and done, if you have 0, 0, there should be a red X right at that center at the origin. And if I move this, it should move along the X-axis. And if I move this slider, it should move along the Y-axis. All right? So now that I have that point, I'm going to plug that into my center of my circle. And then a green circle, or it might be red, depending if you have it clicked or not, will pop up right around that X. Everybody following along so far? I'm just going to leave the radius as is for now. So I'm not going to change it. As you can see, it automatically sets the normal. We talked about normal, right? Everybody remember what normal? Somebody tell me what normal means?
So axis that it sits in.
Axis that it sits in. More of that, not necessarily the axis that it sits in, right? The axis that it sits in, or the plane that this circle sits in, is actually the XY plane, right? Not in the Z coordinate. But it's hard to see; it's a little blurry. But if you see that, like when I hover over the normal, it says 0, 0, 1, and that's X, Y, Z. So it's saying my normal is in the Z direction. So that is a point that is perpendicular to the surface of the circle. So from this point, the direction that is perpendicular is in the Z direction. This is like something that it's going to take a long time if you don't kind of grasp it instantly. I promise you'll eventually get it. But does that make sense? Or at least enough for now. All right? It's not the plane it's in, it's the plane is perpendicular to that. It's the simplest way to say that. All right, so I have a circle. Everybody follow me. Everybody got a circle so far around a point. Feel good. Martin does not have a point. Circle. Okay. Zoom in there. It's a very tiny circle, but it is there. Good. Just noticed something. Let me see. I don't remember where this button is. Okay, so I find it easier this way. You guys, it makes your graphs a little bit larger. I just noticed on Martin and some other people's. Your nodes right now look like this, right? It's a little hard, at least for me personally, this is a little harder to read if you don't know what you're looking for. So if you go to display and you click on draw full names, it will show, it'll write out X coordinate, center, radius, all that stuff. It's a little bit easier to follow along. Yeah, there we go. Okay. I realized I always forget to share that because I have that on all the time. So, and I always remember at the moment when I see somebody else's screen for the first time. So that should make it a little bit easier to understand what goes in and out of stuff. All right, everybody else good? Circles drawn, goes comfortable. All right, so The next thing I'm going to do is I want to take this circle and I want to create a bunch of them. I want to create an array of circles, right? You know. So what I'm going to do there is on the little loopy arrow tab is the transform tab. So this is how you change things. You scale them, you copy them, you move them. You're affecting some sort of object. You're transforming it. And I'm going to create a rectangular array. Okay. So in the transform tab, under the array section, there's a rectangular array right there. Pop it out, and you will see, when you drop it in, you'll see this box, right? Yep. So at the top, there's 5 or 6 tabs over. It's called transform. Click on that. In the second, collection, we'll call it, there's something called array. And the top right should be the rectangular array. If you don't see that, you can click the drop arrow and you should be able to see it somewhere. Okay. So what do I need? So I need a geometry. You need a cell, which we're actually going to skip over, and then we need an X count and a Y count. So what do we think we're going to plug into the geometry? Bam. You guys are smart. Boom. So I drop that in and I should automatically have a bunch more circles. 3 tall, 6 wide. Right? Because if I hover over the X count, it's hard to see on the screen, but it says the defined value is 6, meaning it's automatically being defined as 6. If I hover over the Y, it should say automatically being defined as 3. So let's say I wanted to change that. What should I plug into X and Y count? What can I plug in there to dynamically change that around? Sliders. We love sliders. Sliders are our friend. So I'm actually just going to copy one of these sliders, bring it over. And let's say we wanted it to be a perfect box. We wanted the same in both. I can just plug that slider into both X1 and Y, and now I have 5 and 5. Right, so if I change this, they start to grow. I can make it as big as I want, as small as I want. So the rectangle, as you can see, or the cell, what it's saying is a cell, what that is telling me is what's the spacing of these, right? So if you wanted to change that, that's where we would change that spacing. We're just going to let it be the spacing how it is for now. We're not going to get too deep, but you can see the rectangle that it draws here. And it's kind of basing that spacing off of this rectangle. Yes?
Did you put another slider to change that?
To change the cell?
Yeah.
You actually have to plug in a rectangle to that, I believe. Some sort. So if I wanted to... hold on a second. The professor was having... Okay, I figured it out. Alright, so... we'll ignore that. So we are going to, I believe, plug in a rectangle. So I could plug in, so I need a plane, X, Y. It also has a radius for, so you now see I have a square there, right? Because it is 5 by 5. And then I believe if I plug that rectangle into this here, you'll see that they all shift. So then if I change this, they all grow based on that. Change this. Does that make sense? There's other ways to do arrays. This is just the one I happen to choose. So I'm just going to leave it like it is for now. And put a bunch in there. Yes? Unhook. So you're going to select. So what do you want to unhook? So if you click on the Y and you hold, let's forget, I think it's control. I can't remember it. So if you click, see how it's hold control and then plug back over. See how it's like, select what you want to unplug, hold control, go back to where it's plugged into. I kept using the whole. Yeah. That's a common moment then. Everybody else feel good about where we're at? Yeah? Isaac, we're still good? We still got you?
Yep, good to go.
Awesome. Okay, so now we have a bunch of circles, and you can make them as big or as small as you know, however many you want. Doesn't particularly matter. So what I'm going to do is, this seems counterintuitive. There's, like I said, there's 1,000 ways to do this, but this is just the first way I thought to make this happen. You could do the attractor point in a bunch of different ways. These aren't going to be our final circles, right? These are just, we're just creating kind of like, I probably could have put points in, moved them around, it may have been easier, but we're learning, right? So what these are going to be is just the center points of my eventual circle, right? So I basically created this array, and now I'm going to find the centers of all of these circles. So that I now have all the different points that are at the center, right? So what I'm going to do is, I'm going to take, if you see, you'll see here, if you hover over the geometry, I have 64 different circles drawn out, right? So I'm going to find the center points of all of those circles instantly, right? There's a tool that you'll also use a lot. I just realized why I started to see it's all black up there. I'll try to move it. There we go. That's coincidence. All right. So it wasn't working before. Now it did. So I'm going to use a command to find all of those quickly, right? It's going to seem counterintuitive, but this is a command. This is a node that you'll probably use a lot, especially in your projects or as you move into Grasshopper deeper, which is, I don't know where it is. That's the problem. Let me see if I can find it. I know how to, I always, like I said, I type things in a lot, so it's hard for me to find sometimes. Okay, here it is. So in the, I think this will work, in the surface tab, so 1, 2, 3, 4, 5, 6 tabs over the surface, there's an analysis section. And then in that analysis section, should be right on the top, if you can't see it, you should click the down arrow, is I'm going to find the areas of all of these circles, which sounds like, why do I care about the areas? But if I drop this in here, what you'll see, and what I want, is that if I plug a geometry into here, it gives me the area of that geometry, but it also gives me the centroid of that area. So it'll give me the center point of anything I plug in there. So if I plug this in, you'll see that little X's pop up in the middle of all your circles, which is all the centers of all the circles. Right? So I've instantly found all those points. I also, coincidentally, if you wanted to, you know the areas of all of those. Right? But more importantly, I got all my points nailed down. The best thing about this, being that it's all still, everything we've done so far is all in Grasshopper. If I change any of these things, if I move my circles, I change the number of the array, it just keeps calculating. It just keeps telling me where those new circles are, where those new centers are, all that fun stuff. Everybody follow along so far? Okay. So like I said, these surface circles are not my final ones. I'm going to create new circles at all of those points. And I'll tell you why when we get to that. I'll tell you why I'm creating new circles and not using new ones when we do it. So to make it easier to see, I'm going to hide all those circles. So I'm going to actually select everything that we've done so far, except for the final one. Middle click, and I'm going to click the little blindfold, which should bring us just to the X's. So just like all I can see is X's. They're all still there. If I unclick the blindfold, I'd be able to see all the circles again. They're still there, and everything still works. It's just showing me only that last one, and you'll see that they turn a little bit of darker gray. The node turns a little darker gray, which means it's it. Yes, Julianne. So I selected everything except for the final. And then I middle click. Do you have a middle click? And the guy with the, there we go. Yeah, I know. Anybody else do it? Awesome. Alright. So everything's still connected. Everything is moving. Perfect. You know, it's always good to flex things as you go to make sure that it's still working and nothing's broken. So I'll do that a lot. I'll go back and move sliders just to make sure everything's still working. Alright, so now we have the area. So now I'm going to create my circles again. I know it seems counterintuitive, but I'm going to drop a circle at all of the center points again. So I'm going to actually go back. I'm going to go to Curves, Primitive. I'm going to click the same circle with center. And now I want to create circles again. So what should I plug in to the center? Centroid. And if I plug the centroid into there, all my circles come back. The difference is that now if I hover over circles, I know, that's weird. I statically shocked my computer and it blinked. If I hover over my circle here, you'll see I have a list of 169 circles. So if I was to, we talked about this in the first tab, what's called a panel, which just tells us what's coming out of something. Doesn't actually do anything, it just shows us. So you'll see that I have all kinds of circles, a whole list, 168 of them. If I plug this into that first circle that we created, I only got one, right? So if I change the radius, on that first circle, I'm changing them all because I just copied that circle a bunch of times. So if I change that 1 to 10, all of them change to 10. But now, with here, at this point, I can technically, whatever I plug, if I plug in a number for that. So if I just make another number slider, I'll copy the one we have into here. And you'll see that I now have all the circles are changing, which is what we would expect on the first one. But if I plug in a list of numbers that is equal to the same amount of circles, so if I made a list that was 169, I'll turn this down a little bit so there's not so many, that was 63 numbers long, right? So I have, you can't see it that well, but I have 63 circles now. You guys may have different numbers. If I plug in a list of numbers to that radius that is 63 numbers long, I'll change each one individually, right? Right.
Did you get that panel to show up?
Yes, sir. So panel on the first, you can type in panel, sure. If you want to find it on the first tab, the third collection over is called input. That's a little, it's yellow with a little scribble at the panel. All right. So we're trying to create an attractor point, right? So I'm trying to create something that changes all of these different radiuses. So if I want to change each one individually to be something different, I can plug, like I said, you can plug in a list of numbers that's the same length as the circles that you have, and you can change every single one of them differently. Okay? Does that make sense? Sort of? If I just plug in a list that's not as long, it'll just repeat. So if I plug in a list of numbers that's 3 items long, the first 3 circles, 1, 2, 3, will change. And then it'll start the list, it'll start the numbers over again and go 1, 2, 3, 1, 2, 3, 1, 2, 3, all the way through, right? But if I have the same amount of the list, it'll just go through all of them. Follow? Okay, so now I got my circles, but I'm gonna unplug this. I'll leave plug in. So, delete that. So now I'm going to create my point, my attractor point, the point that will affect all of these. So I'm going to do it the old-fashioned way. I'm just going to drop a point somewhere. So I went into Rhino, clicked on the point, drop that point wherever you want. And I'm going to, in the first tab, literally the first thing, there's the point. I'm going to grab that, drop my point in, right-click, set one point, and select that, right? So now I have two separate things in here. I have my point, that is my attractor, and I have all my circles. So if I want the radius to change based on how close the center of the circle is to that point, what's the next bit of information I need to find out? How close all those points are to that point. What's another way you might say that? What's the distance? Perfect, that's the node we need, the distance node. So if I go into vector, which is the fourth tab over, there should be, in the point collection, the very top middle, there's a distance node. And the node wants us to point A and point B. So what do we find the distance to between? So I could just have 2 points and say where the distance between these 2 points. But I can also plug in a single point and then a whole list of other points, and it'll tell me the distance from all those points for that one point. So what's the first thing you might want to plug into this distance? The point we selected, as I assume somebody said, sorry. Then the centroid, perfect. So then if I do this, I plug the centroid in, and just for funsies, we'll look at this list, and you'll see, hopefully, you have a list that should be 63 items long. It's a bunch of different numbers. It's a list of numbers. And that should be, we did everything right, the distance from that point to that one, that point to that one, that point to that one, all the way through. If I grow it, that list will grow. If I shrink it, that list will shrink. Dynamically, will, it's all in, except for that singular point, which we could make in Grasshopper. Everything should be in there. So now where do we plug that distance list into? What's that? The radius. So if we plug that into the radius, fingers crossed, get craziness. And if we move this, remove the point that's in we get all kinds of different circles. But this isn't really useful to us, right? This is kind of crazy pattern. So what's something we might want to do to make this a little bit more, I don't know, not as crazy as a pattern. What if we didn't want the circles to be this large? So we're making some of the radiuses, the radii of these circles 64 feet, 12 feet, 60 feet, making them pretty large. So what do we want to do? If we wanted to process a little differently, what's something we could do to those numbers to make it a little more useful? Divide them, okay. So we're going to take that number and we're going to process that list and bring it down to something else, right? So we can go to, so we're going to divide them. So what would you do to divide them? What kind of, where would we go to find the division? Math. What's that? Yeah, that's how I do it. It's how I would have thought too, but try to click on things so that everybody can see it. So in the maths, there's operations or operators. We can divide. So this is just a math node. So we can say, so what do we want to plug in? So where should we plug the distance in? Plug the distance into A. What should we plug into B? Slider, okay. What do we want to do? I'm going to type in slider. I always type in slider. I plug that in just to see what we get, just with whatever the natural pops out. So now we're getting crazy numbers. Now it's going to be much larger. So we may want to adjust that number slider, or maybe I'll make it integers. Let's make this all the way up to 1,000. Oops. I went to 0. So now you can see if I adjust it, you know, to a bigger number other than 0.25, those numbers shrink drastically. Right, so our first number in this list here was 16, and now our first number in this list is 0.5. So if I plug this into the radius, now we get a little bit more manageable circles. And if I adjust my slider, I can change that relationship. And like I said, since all in Grasshopper except for that one point, I can zoom out here.
You have a second point that has the same effect.
So what do you want to do? I'm sorry?
I have 2 points that both contribute to the radius.
So what are you suggesting?
So like we have 1 point where it's the circle goes small, and around it, and then we get larger.
Yep.
And then the point at top and the point down bottom, and we both do the same thing. And we're both in
So you want the circles to be affected by 2 different points, or do you want the 2 points in their relationship to each other to affect the circles?
just the circle to be affected by it.
So like if I had just, for funsies, if I put another circle here, or another point here, this one would be smaller and it would grow out. So we can do that. Let me think about that for a second.
I'm not sure if that like messed up, but like that's what was like
Too large.
yeah. Let's do like number
So you still have the big distance plugged into the radius, so you need to plug this result. Oh, so this is still the big one. Now, anybody else have any issues? Oh, it's sorry. Okay, so divided. Okay, so right now your circle is so big, you know why they're so big? So you got your distance here, and distance is still the large number, and the distance is plugged into the radius. So the radius of the circle is still being controlled by the bigger number. So if you want to be controlled by the smaller number, you have to plug that result into the radius. Now you're going to have a bunch of probably changes.
I didn't know where to find
That's okay, not a problem. It's a collaborative class, just technology. Okay. So where do you go wrong? Oh, so this guy right here, this point, this isn't selected. So it's still orange. You never selected that point. So if you right click on it, there you go. Now you're crazy, right? Now, so similar to Alexis, did you do the division on this? Okay, so if you do the division, then you'll need another slider. So you do a number slider. That's okay, not a problem. So we plug, what we did is we took the distance, we plugged it into there. That's the top. Numerator. And we're going to plug this into the bottom, that's the denominator. We're going to make this number a little bit larger. So actually, want to double click on that slide. So we're going to change the maximum to be like, just need to get this. And then, you're going to slide that up into the 10 to 20 range like this. I know. Yeah. So if you plug that, just to see what's coming out, if you plug that into there, you'll see, all right, we have a lot smaller numbers. So to get the radius. So what if to change the radius to these numbers, what do you think you should do? So we have the radius of the circle up there. So we want to make it. So I want to change. You have a bunch of big radii, right? We want to make the radius of these circles. We want to make it those numbers. So what should we go against the there? Change that. Okay. Yeah. So we want to take the result. That's the number. Put that. So now we got and then you adjust that. Then the slider change. You know. Oh, I can do that. Everybody else? Okay, so you're probably still showing the original as we did. So probably in that. So you're showing everything. So that right there. You click on that. You select. You see that the little subview. Those are good. Yeah, I was just fine. So all that stuff is still happening in the background. I was just making it more easy to see. Cool. Everybody else feel good? Yeah. We got our first tractor point. So back to our other question, Zach. Got it. Brendan. I keep forgetting Brendan now. I got Evan on my mind. Zach. So Zach asked 2 points, and dependent on. So this is a little bit more advanced. We'll try to do it. No problem. So we got 2 points on here. So let's just do that. Let's just put another point in. Oh man, now I'm thinking about it, it's going to be.
Too much, man.
I'm trying to think of the simplest way to do it. So let me just explain why it's a no. Maybe that's the thing. Maybe I can't even think of how to do it. I know what I need to do. I just don't know all of it. So what we've done here, what we have done at the moment is we have created a list of things and a list of numbers, and we've related those lists together, right? A list of circles, and then we change those circles' radii by plugging in a list of numbers. Seems simple enough. Lists in Grasshopper can get very, very complicated very fast, right? So this is just a single list, 0 to 60 something. Lists can have lists inside of themselves and inside of themselves and inside of themselves. They can get really complicated really fast. So we have done very basic list manipulation. We'll get deeper into list manipulation as the semester goes on, but for right now, this is as much as we're going to get down. So what Zach's asking is we have 2 points that relate to the radii of the circle. So 1 point is the closest point to this circle. That would be small, and they would kind of, they would get small and large. So what you're asking is, right now we're evaluating where is the center of the circle to the point. What's that distance, right? That's what we're currently evaluating. But what you're asking Zach to evaluate is, now we have 2 points. So I want to know the distance of all the center of the circles to both points, right? So I still need to find the distance to both. But then what I want you to do is tell me which point is closest, right? So then I need to compare those lists together and say, for circle 1, point 1 is closest, but for circle 10, point 2 is closest, right? So then I have 2 lists of distances. I need to say, all right, tell me the smallest distance, or largest, whatever. And then I need to take those lists and put them back together again and say, I want all the small, look at each single circle, tell me which one is the closest, which point is closest, take that number, put it in a list. Now look at the next circle, tell me which point is closest, take that number, put it in a list. You know what I mean? So we're kind of evaluating, we're finding out 2 bits of information, we're evaluating them against each other, and creating a new list of numbers, which a little complicated right now. It's, honestly, I might be able to figure it out, like, if I work through it. It's gonna be messy. You guys are gonna be like, what is he doing? I'm gonna have to, like, go silent for a minute and, like, not listen, not talk to y'all. So it's just a little bit of complication. You can do it. You 100% can do it. And I promise you, before the end of the semester happens, we will do it, and I'll show you how to do it. But I need to plan it a little bit better, so that way I'm not talking you into a rabbit hole of nonsense, and give you an efficient way to do it. But you can do it.
Okay, in order to generate this, like, not the circles, but basically like the track point, what would you call it?
The attractor point, yeah.
Yeah. Do you need like the list at all, or could you just do like that second? Like, are the lists necessary in order to change the radius of all of those? Because I'm looking at in like the where we did the point and the number slider for the division. That's being plugged into a list, which is then being plugged back into a radius. But you can just plug from like division result directly into that radius. Like, do you need to have that list node up there in order to do what we do?
These yellow things?
Yeah.
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 Those are purely just to understand what's coming in. I could literally go here. I can select this, delete, select, delete, select, delete. Nothing changes.
And it'll still.
It's all still functioning the same. I can change this. Can't go to 0 because you can't divide by 0. I can, change those. I can move this point around. Move it. I could even move this in Z direction. It's still calculating. All it's doing is telling me straight line here to here. What's that distance? Straight line here to here. What's that distance? So it'll go any direction. The panels are purely, you can get the same information from the panel just by hovering here, like hovering over what the end. But you'll see it only shows you a few of the numbers, and then it says it goes all the way. There's 64 values from here to here, right?
Yeah.
So I just want to see what those numbers look like. If you ever what's going to happen? Some of you will happen is like, when I plug this in, nothing happens. Like, what is happening in here? I don't understand what's happening in here. And just plugging a panel into there just shows you this is what's popping out,
Right.
and this is not what you need, right? So like if this, for example, if I wanted to break this, let's say I plugged in, I'm just going to plug in this geometry into the radius. Well, that actually worked. That's kind of funny. I don't know why that worked. I'm going to do this. It's kind of funny that's working. I'm not 100% sure why that works. I was trying to break it, now I can't even break it. Normally I break stuff and I can't figure out how to fix it. There we go, now I broke it. So now nothing's happening. I have an error, a red node, and it's telling me, hey, this is failing. And what it does say, if you can't read it, it says data conversion failed from transform to number. And you may or may not understand what that means. It's pretty easy to understand what I did. I plugged in something that's a transform thing into a node that wants a number. But let's say you didn't know that, and you're like, what is coming out of this node? What is it? What is it that it is screwing up? So I can plug that in, and you'll see that it is a series of commands. It says move, and it tells it how far to move it and how many directions, or in X direction and Y direction, or whatever. It's just telling you where it goes. So it doesn't know what to do with it, right. So if you didn't understand that, obviously you didn't understand, but if you did, this should work. I don't understand why it works. You can just plug this out and be like, oh, okay, that's why. These are numbers. Maybe convert these to numbers or find a way to make numbers out of those. So it's just a way to test things and and make sure that just see what's coming in and out. Because like I said, lists get complicated. This is like pretty simple lists just from where do lists start? What number do lists start at? We talked about this last class. 0. Lists always start at 0. So the first item in a list is the zeroth item, not the first. So if you want to get the first item in the list, you're looking in the 0 position. If you want the second item in the list, you're looking in the 1 position. It's a pain, I know, but we'll get used to it actually. The coding thing. So these are pretty simple lists, just from 0 to 62 or 64 or whatever. Like I said, lists can get complicated. You can have 10 lists with 30 items inside each of those 10 lists. So a list and a list. So you have a list of lists. You have a list of lists of lists, and a list of lists of lists of lists, and go deeper, deeper, deeper. So that's when the panel really comes into play, because you're like, why is this not working? And you see, oh, there's multiple lists with items inside of those lists. We'll get into that deeper. Any other questions or concerns about this? You all right? Okay. So, what else do we want to do? So I promised Zach we will do the double point at some point. Is there anything else you want to try to do with this? What point do you want to do with this? Something simple, really. So you want the circle in a circle.
Yeah, so you guys are looking at the World Series trophy, kind of like that.
Okay. Well, so that's like different heights too, right?
Not different heights. I'm just saying, like in the range of it. I'm talking about the height.
Okay. All right. You might be able to do that. Let's see here. I'm gonna go to transform array. So we have a polar array, right? So we can create. Okay, so this will teach us something about this, right? So I'm just gonna copy this down. So I selected everything, Control C, Control V. Now I have 2 completely different arrays. I'm gonna move the first one out of the way here. So that first array is over there. You see that it's changed. The circles are still changing, right? Because they're still related to that point. So now they've adjusted to that point. I just wanted to keep that, just in case we need to go back to it. So where do we want to set this in, Haley? Where should we start trying to think about replacing this to do what you're suggesting?
Hold on. I don't know how I got. How did you just move that whole, like?
So I moved the point.
Yeah, but when I moved the point.
No, wrong point. So that's the attractor point, right? So I moved this point, the initial point, which is where this whole array starts from. So if you change those number sliders. And you may need to adjust your number slider to have a bigger maximum. So I just moved their starting point off into the distance.
I didn't know.
No, I did it quick. Everybody understand that? It's all good? Okay, so Haley, back to where we're at. What do we think you might want to start replacing in order to? Do you want to take this rectangle array and make it into a circle?
Yes, I guess you would take.
Okay. So I'm gonna put the circle into the geometry, like so. So now what happens? I now have an array of circles in a circle over here, right? So I'm just keeping them in the rectangle for now. So what else might you want to plug in to change it? Number slider for the count. I'm just going to copy that number slider, plug it into the count. Boom, we got more circles now. And so that's, you know, pretty much doing what we wanted to do. We could change the plane if we didn't want it to be on the XY. So this is something we can at least talk about. So right now, there's an angle. Does everybody know what the angle anybody have an idea what the angle might mean for the radial array?
Is that the space between the circle?
Not necessarily the space. It will affect the space. Just think back to I don't know, what would it be? Maybe trig or early calculus? I don't know. I can't remember. Yeah, right, trig. Yeah. So you remember radians? Okay, remember what that was? It's like a version of degrees, right? So like it can be 90 degrees or 2 pi or 1 pi or whatever that is. I can't remember. So what the angle is saying, so right now it's defaulting to a full circle, right? Which if you hover over it, it's 2 times pi, 2 pi, which is a full circle, meaning that it will array those circles in 360 degrees. Does that make sense? So if I was to change the angle, I could get it to only array 180 degrees, or 90 degrees, or 45. But it'll still put the same amount, so it'll affect the spacing, because it'll take 11 circles and fit them into that pi shape. So if I wanted to do that, so you understand. So what it's asking for, if I hover over it, it says sweep angle in radians. So I can't just plug degrees into there, because it won't make any sense. I need to plug radians in there. But I personally don't think in radians. Do you think in radians? Everybody remember what the heck radians are? Okay. So what I tend to do when it's asking for things like this, especially radians, is there's a converter where I can plug in a slider that can go from 0 to 360, which is a full circle. We at least know that. And it'll convert that number into a radian, right? So I'm going to make a slider. Number slider. I'm going to change this to be integer numbers, and I'm going to go its maximum to be 360 because the maximum we want to do is a full circle. And then I'm going to, I don't know where this is, so I'm going to type it in. Is it this one? Yeah, okay. So I'll just do it again. If I double click, if I type in radians, that pops up and it gives me a little node that says degrees in one end, radians out the other. So I can plug in my number slider that is my degrees into there, and then I can plug my radians into angle, and you'll see that I've now shifted those circles into a smaller, so I can go all the way up to a full circle at 360, or I can back it off, you know, down to 180-ish, which should be half a circle, 180, and so on and so forth. Or I could do nothing, not plug anything into there, it'll automatically go on a circle. So, that being said, the last thing we would need to do to comply with Haley's request is I need to swap out this this array. So I need to take the geometry that's coming out of that array and plug it into this, and now I have a bunch of circles that are related to this. I'm going to hide this because I'm seeing 2 circles at once. I'm going to middle click on the array, put the blindfold on, and now I can see that I have circles that are changing in size based on how close or far they are away from my attractor gun. Cool. Let's do something else. So 2D things aren't that cool. Let's make it 3D. Let's make it 3D. So we're gonna make it 3D super easy. So I just moved it back over to that other array. They're both still happening. But I'm gonna do it over here. So that is, I'm gonna move this down out of my way. Oops. So I'm working up here. So what would I want to do? What can I do to make, what's a tool that I would use in Rhino, pretend we didn't have Grasshopper, if I wanted to make these 3D? Extrude. All the tools in Rhino exist in, I think all plus more exist in Grasshopper. So I'm going to go to Surface, I think it's Surface, and in Freeform, so the second collection over, there's an Extrude command. Drop that in. It's asking me for what is the base and what is the direction. Okay, so what do we think the base might be? So of this, I kind of pretty simple. But what do we think the base? What do we need to plug into the base? These circles. All right. So if I plug in those circles to the base, nothing's happening. The direction, but what is it? Vector. Okay, so it needs a vector. How do we get a vector? So what direction do we want to extrude it in? So you want to go that way?
Oh, no.
Z direction. That's okay. No, that's. Yeah, so this is the Y direction, the green. The red is the X. We want it to go in the Z direction. We want it to go up and out. So where do we find vector? Anybody remember? The vector tab is a little arrow on it. But at the very end, there's a collection of, it's called vector. And we want to move it in the Z direction. So if I take this out, I have a unit vector in the Z. I plug that into the direction. It's extruded them all by a, so sorry. What has it, what is this dimension? Why is it doing it, whatever that dimension is? Anybody have an idea? Or did everybody get to that point first? You have a little extrusion, a little cylinder. Anybody know why it's only whatever top? Yeah, it is the default. So if I hovered over this unit vector here, you will see that it is 0, 0, 1, meaning it's going in the Z direction by 1 unit. So if this is feet, it's going by 1 foot. If it's an inch, it's going by 1 inch, a meter, 1 meter, whatever the units are in this model. So this isn't that interesting. What can we plug into? So to change that, we can plug a factor into here, which will change the height, right? So we can plug in a slider. Sliders are our friends. Let's make it 100 for fun. Make it integers. I can do 0. Now I got nothing and I got an error. Or I can extrude them up dynamically however I want. But what's more interesting than 14? All it's asking is for the number.
You could do
the distance, so the attractor point, right? So you could say, let's say I don't want to do the measly little division thing we did. I want it to be a little bit more substantial. So I'm going to take that distance, which all it is a list of numbers, and I'm going to plug it into that factor, and now I should have, not only is the radius changing by how close it is to the attractor point, but the height is changing, right? So if I find my point, I don't know where it is, there it is, and I move my point around, I can change all of those however I want. If I wanted to memorialize this. So still up till now, the only thing that's actually in Rhino is that point. Nothing that's in Grasshopper is actually in Rhino. It's all just showing you a preview of what could be in Rhino, right? So what do we want to do to put it in Rhino? Bake. I'm gonna bake it. So I would click this last option here. I'd right click it. I can bake it. Pick a layer. Let's make it shaded. And now I wanted to move these off side. I have a memorialized version of that. But now those are disconnected. Right? This pipe organ that we've created is disconnected from the attractor point. So if we wanted to change it, those aren't going to change. Everybody able to get there? Make sense? Feel like we feel that we understand what's happening, or do you think that you just followed along and achieved the same thing, but only because you clicked the same things I clicked? You can say no. I won't be offended if you're like, Dana, I have no idea what the heck you're talking about. With that? I heard a grumble. Brendan.
I think I lost things on that part where you kind of like regularly change the IC. Only because I was playing around and I stopped around it.
No, that's okay. So you didn't get the same variation of height?
I was just able to shoot it, but like not very.
So
Yeah.
So what you have is that. You see that?
Well, yeah. We do change the direction.
But you have just like little height circles?
Yeah. So like. Yeah. Because I was doing I was trying to do with the result.
Just be different. You confirm. So they're all the same. Right. So I use a different vector tool.
Okay.
So you create your own vector.
Right.
So which is fine. You can keep that if you want, but it's the height is dependent on that slider there, that 71. So if you slid that slider 71 up and down, you would go up and down. Right? So all this node is doing is saying, oh, you're going to build a vector. Right. So if you had a vector that was in a weird direction, not X, Y, Z, some combination of those, this is how you're going to do that. But it's doing the same thing. So all you need to do is plug. All we did was take the distance that we got earlier and plug it into that. So if you turn that, plug that into where that 71 was going. Into that Z node. Now they're going to be all different. Cool. The node that I use is just a Z vector. It's just only Z. So if you go back to vectors, if you click it down there, vector, they have just Z, X, Y, Z. Okay. Yeah, so I just use these because I know it's only going to go up. So what you did isn't any worse or better.
Because for a second I thought you were changing the point button down on the item, like just way.
Yeah, so now if you do change that point, they all will change. If you move that point down there.
Yeah, because now it has the data.
Yeah, so it's referencing where that point is, where all the symbols are. Extremely appropriate. Cool. Are we going good? Oh, we got some. Medium going on there. When trade, that's gonna happen. What do we got going on? Oh, you know, like, bare minimum, right? So we click on that, okay. That's the, oh, this is big, this is a big thing, right? Okay. So this one, okay, so you still have, okay. I can click on, where's that? Okay, so you got a real big, really big number. Your radii are enormous. So if you increase that slider, you're in the, you still got the radius. So you have to go bigger to make it. Where's the point at? Over here. The point is what? Okay. Can you move it closer? Yes, that's not too far. Anyway. Yeah, just because it was so far away, the distance is crazy. Now you see, now everything's changing, so the radii are changing and the height are changing based on where that's going. They just happen to be so far away. It's crazy. You're good? You good? What is it? Sure.
So after like when I I noticed like this vector here for like let's say you're like
Yeah.
so like let's say you're going to do this. Go this way. And then we like this would be like a separate cell. Rather than I think the one we will want to get to be like specified in average one. So like where this is going to go, what we're gonna do is the rest of
You put a panel, so this is an instance where I need a panel. I want to see what's coming out of that vector. And assuming with the dash line, the multi-list.
Yeah.
See, this is an example of two lists. So the dash line is basically saying, hey, multiple lists are coming out of this node. So they're coming out because you're plugging code because you're plugging two different things, right? So it's creating one list that is all the distances, and it's creating another list that is just that one. So when this comes out, it's basically saying, hey, you're now creating two different sets of the same thing. One set is related to just this height, and the other set is related to that distance. So you unplug one of those, you get control unplug that, now you only have one. You do the reverse. So you plug two in there, you can see now there's only one list. So when you see that dash line, that means you have multiple lists in that. Which I said, we'll get into that. Or maybe we'll get into that sooner, but that is a little bit more good. Cool. Everybody else? We're good? We're good? We're our first attractor point. That's exciting, right? We're not excited? We're not pumped? We're like through the roof here. Isaac, do we still got you?
Yep.
Any questions on your end?
No, I'm good.
No, you're good. You're a pro over there. I got nothing. Okay, so we're going two different directions here, driving a little crazy. Here we go. Okay, so I think that's probably the limit of what we can maybe grasp in one class in terms of Grasshopper. Still pretty basic, but we took our circles, we created a whole array of other circles, and we all of the data relate to each other, so that way as we change some things, other things are changing, right? There's no, and the reason why I show this attractor point, this is like a very simple version of this. Most architecture projects, if you were to use Grasshopper, attractor point isn't all of that, unless you're like, oh, that point is of interest. There's some bit on some place on the site that's of interest, and I want my facade to react to that singular spot. Maybe you can do that, or maybe you're generating ideas for a facade or generating ideas for a building or something. But ultimately, an attractor point isn't that interesting. But what is interesting, maybe, is what I like to get out of this, I guess, is that we're just tracking numbers, right? We're just taking a distance from one thing to another. We're getting that list of numbers, and we are plugging in. There's no reason why that list of numbers can't be the amount of sun hitting one of these points on a facade, or a person and their proximity to something, right? Or the wind direction and speed, or where that James Webb Space Telescope is in its trajectory, if you've all been following that. You know, we could track anything, we just need numbers to do that, right? So this attractor point tells us that shows us that we can take those lists of numbers, process it, and then have it affect something else, right? Eventually, later, throughout the semester, I'll probably take you through an example where I create a sunshade, where I get a form, and I can see how much sun is hitting that one individual spot, and it can open and close based on that amount of sun. If it's too much sun, it closes. If it's no sun, it's open. But that sounds complicated, but all it is taking points on a surface and saying how much sun is hitting that point, and then manipulate these objects based on that thing, right? So it's definitely more complicated than these circles and extruding them, but it's at its core, it's the same thing, right? Cool. Let me stop recording here.